So this question is engineering thermodynamics question that appeared in IAS exam 2004 and which is of 30 marks. So let us solve this question by first reading the question. A pressure vessel is connected via a valve to a gas main in which gas is maintained at a constant pressure and temperature of 1.4 meganewton per meter square and 85 degrees Celsius respectively. The pressure vessel is initially evacuated. The valve is opened and a mass of 2.7 kg of gas passes into the pressure vessel. The valve is closed and the pressure and temperature of the gas in the pressure vessel are then 700 kilonewton per meter square and 60 degrees Celsius respectively. Determine the heat transferred to or from the gas in the vessel. Determine the volume of gas before transfer. For the gas, take Cp is equals to 0.88 kilojoule per kilogram Kelvin and Cv is equals to 0.67 kilojoule per kilogram Kelvin. Neglect the velocity of the gas in the main. So this question is based upon the steady flow equation. So we can just solve it using steady flow energy equation. So let us try and to understand what is shown in this question. So this pipeline gas is flowing like this. Now this valve here, this is a valve, it is now open. This is a chamber here. See, now chamber is shown here. Now it is initially evacuated, so P1 was 0 here, and then when valve is opened, so now it is open, then that P2 changes. P2 now comes out to be 700 kilonewton per meter square. T2 comes out to be 333 Kelvin. M comes out to be 2.7 kilogram. Now this gas comes in this pressure vessel, so we can assume this valve and this vessel as a control volume. When we apply the conservation of energy theorem here for the variable flow process, rate of change is equals to dEV divided by d tau, where tau is the time. Now dEV by d tau comes out to be H is equals to U plus PV. So this comes out to be HP multiplied by dm by d tau plus dq divided by d tau. So du by d tau comes out to be HP dm by d tau plus dq by d tau. This comes out to be the equation for this control volume. Now when we integrate this, we get M2U2 minus M1U1 is equals to HP multiplied by M2 minus M1 plus Q. Now this is the fundamental equation. Change in internal energy is equals to the change in enthalpy. This is change in the uh, heat transfer. Heat transfer to or from the pressure vessel. Now Q. We know that M1 is equals to 0, so M2U2 minus M2HP is equals to Q. Now Q is equals to M2 into, now U2 is CvT2 minus Cp multiplied by Tp. Now this comes out to be 2.7 kg, because in the question it is mentioned the mass to be 2.7 kilogram that flows into the vessel, and the value of Cv is also given in the question, that is 0.67. T2 is also mentioned, that is 333 Kelvin, minus Cp 0.88 multiplied by 358. Now this comes out to be minus 248.211 kilojoules. Hence 248.11 kilojoule of heat is lost from the vessel because the sign comes out to be negative. Now we can assume ideal gas behavior. Pp multiplied by Vp divided by Tp is equals to P2 into V2 divided by T2. Hence this comes out to be Mr is equals to M multiplied by Cp minus Cv, thus Vp, that is volume, comes out to be 358 into 2.7 into 0.88 minus 0.67 divided by 1.4 into 10 to the power 3, which comes out to be 0.145 meter cube. Now we have found this Vp. Vp is equals to volume of gas before filling. It comes out to be 0.145 meter cube. So it was a easy question for 30 marks. Just we have to apply a steady flow equation here. Now first we have to determine what should be the our control volume. Now rate of change of energy per unit time comes out to be this equation, and when we integrate we get the change in internal energy is equals to the change in enthalpy plus the heat transfer. Now we know that it is initially evacuated. Uh, it is initially evacuated. That's why M1 was 0. Now M2U2 minus M2HP comes out to be Q. Now Q is equals to M2 into CV T2 minus CP into TP. Now Q comes out to be minus 248.211 kilojoules. Thus, 248.11 kilojoule of heat is lost from the vessel, and when we have found out the heat, we can also find out the volume of the gas before the transfer takes place. Now we know that it is an ideal gas, so it should follow ideal gas equation. Thus, PV by TP should be equal to P2V2 by T2. Thus, Vp we can get by P2 multiplied by V2 multiplied by Cp minus Cv divided by initial pressure. Thus, we can find out the volume before the filling of the gas.